I've covered a lot of ground on arrays and array lists. This feels like a good place to pause and review these two side by side. This slide demonstrates that arrays and array lists have more in common than they don't. Arrays support primitive types, but array lists don't. Array list supports primitive wrappers. Both are indexed and ordered by that index. Both allow duplicate values and null values. Both inherit from java.util.object and are mutable. An array is not resizable, but the array list is, and I've talked at length about the many methods implemented by ArrayList. On this slide, I show the differences when creating a new instance of an array compared to a new instance of an array list. An array requires square brackets in the declaration. On the right-hand side of the equal sign, square brackets are also required with a size specified inside. An array list should be declared with the type of element for the array list in angle brackets. You can use the diamond operator when creating a new instance in a declaration statement. You should use a specific type rather than just the object class, because Java can then perform compile time type checking. You can use an array initializer to populate array elements during array creation. This feature lets you pass all the values in the array as a comma delimited list in curly braces. When you use an array initializer in a declaration statement, you can use what's called the anonymous version, as I show here. You can use an array list constructor that takes a collection or a list of values during array list creation. The list.of method can be used to create such a list with a variable argument list of elements. The number of elements is fixed when an array is created. You can get the size of the array from the attribute length on the array instance. Array elements are accessed with the use of square brackets and an index that ranges from 0 to 1 less than the number of elements. The number of elements in an array list may vary and can be retrieved with a method on the instance named size. Array list elements are accessed with get and set methods, also using an index ranging from 0 to 1 less than the number of elements. Array lists come with built-in support for printing out elements, including nested lists. Arrays don't though, so you need to call arrays .toString, passing the array as an argument. This slide shows examples of single-dimension arrays and array lists. Here I show examples of multi-dimensional arrays and array lists, and how to print the elements in each. A multi-dimensional array list simply has a type, which in itself is an array list. For a multi-dimensional array, you need to call the arrays .deep_toString method, passing the array as an argument. For nested array lists, we can still just pass the array list instance directly to system.out.println as shown here. For arrays, you can use the binary search method to find a matching element, although this method requires that the array be sorted first. In addition, if the array contains duplicate elements, the index returned from this search is not guaranteed to be the position of the first element. For the array list, we have several methods. You can use contains or contains all, which simply returns a boolean if a match or matches were found. In addition, like the string and string builder, we have the methods index of and last index of, which will return the index of the first or last match. When a -1 is returned from these methods, no matching entry was found. Sorting seems like a simple concept when you think about sorting numbers and strings. We know there is a natural order for numbers and even for strings. We can use the arrays.sort method for arrays with numeric primitive types and wrapper classes, as well as strings and string builders. For the array list, we can use the sort method again for numeric wrapper classes, strings and string builders. You pass a comparator type argument to array list sort method that specifies how the sort should be performed. You call static methods on the comparator type to get a comparator for either a natural order or reverse order sort. There are times when you'll want to switch between an array and an array list, and there is support for this on both the arrays class and the array list class. The arrays.asList method returns an array list backed by an array. Here I show the creation of a 3-element array. Then the code uses the arrays.asList method, passing it the array and assigning the result, a list of strings, to a variable original list. You can think of this conceptually as putting an array list wrapper of sorts around an existing array. Any change made to the list is a change to the array that backs it. This also means that an array list created by this method is not resizable, Let's look at this method in code. I've created a new project called Arrays and Array Lists. I'll add the code that was shown on the slide. String array, original array equals new string array, and 3 strings in curly braces. var original list equals arrays dot as list passing original array as the argument. The method arrays dot as list returns a special type of list, which I'll look at shortly. This is another good case for the var keyword, which lets us declare this variable without knowing the type exactly. Original list is backed by original array. This means I have access to lists methods to make changes to the array that backs it. I'll use the set method on the array list. Original list.set passing 0 and the literal string 1. I'll print out original list and also print out original array using arrays dot to string. When I run this code, this is what we see. This confirms what it means to have a list backed by the array. The list's first element, you can see, was changed from first to 1. But look at the second line of output. This is the output from printing the original array. And here too you can see the array's first element has been changed to 1 as well. So any method we use on this list will have an effect on the array that was the source of the list. Let's try another method. This time I'll sort the list and print out the original array. Original list.sort passing comparator.naturalorder. Print out original array using arrays dot to string. And running this code. You see the array is now sorted. Notice for strings the natural order of sorting is to have uppercase letters considered less than lowercase letters. So we get second, third and 1 in that order. But this type of list has limitations. Because this list is backed by an array, I can't remove or add elements. Let's see what happens if I try to remove that first element. Original list. Dot remove passing 0. This code compiles, but if I run it, I get an unsupported operation exception. Let's change that up and try adding an element. Original list.add passing the literal string fourth. Again this compiles, but if I run it, we get the same error and for the same reason. You can look at what I did here, using the method arrays dot as list as a way of just dressing up the array that's passed as an argument to this method to make it look like a list. It's almost like a list wrapper, but with limitations. You do this when you want to be able to use list functionality to manipulate that underlying array as I did here, sorting of the array, but using list's sort method to do it. The list we get back from arrays.asList isn't resizable, again because its ultimate source is original array, which is an array, and arrays aren't resizable. One other thing I want to show you is that this method takes variable arguments. You can use it to create a fixed size list from a list of elements. List of string new list equals arrays.asList with these 3 string arguments, and print out new list. This code uses 3 strings passed as arguments to the asList method. Here I don't have a reference to the array backing the list because the array is created from these 3 strings within that method. You can use this type of list creation if you need to create a fixed size list. And if I comment out line 21 and run this again, I get my list printed out. I've already talked about the list.of method, which returns an immutable list, and I covered the toArray method in my last video, so I'll just give you a summary of these methods on a slide. This slide demonstrates 2 ways to create a list, from elements or from an array of elements. Both are static factory methods on types. The first is the asList method on the arrays class, and it returns a special instance of a list that is not resizable but is mutable. The second is the of method on the list interface, and it returns a special instance of a list that is immutable. Both support variable arguments, so you can pass a set of arguments of one type, or you can pass an array. I'm showing examples of both here, first using variable arguments and second passing an array. This slide shows the most common method to create an array from an array list using the method toArray. This method takes one argument, which should be an instance of a typed array. This method returns an array of that same type. If the length of the array you pass has more elements than the list, extra elements will be filled with the default values for that type. If the length of the array you pass has less elements than the list, the method will still return an array with the same number of elements in it as the list. In the example shown here, I pass a string array with 0 as the size, but the array returned has 3 elements, which is the number of elements in the list. Okay, so I hope this comparison of arrays and array lists helped you understand the differences and the similarities of both. In general, arrays are more efficient because they are fixed length and support primitive types, but the ArrayList class has a great deal of functionality that we only partially get with the Arrays Helper class. In the next video, I'm going to give you an array list challenge so you can put some of the skills you've learned to work. I'll see you in that next video.